everyone. It is the top of the hour, so we will get going here. Again, just welcome to our webinar for today on how to run and monitor Kubernetes with PKS and Wavefront. We have an excellent presentation prepared for you today. We have two awesome speakers. Our first is going to be Steve Tegeler, who works on VMware PKS. And so we will have him kick things off, and then Pierre will follow.
Hey, thanks, Caroline. Appreciate the intro. Again, everyone, my name is Steve Tegeler. I'm a Senior Director of Systems Engineering here at VMware. VMware has a dedicated team of folks that cover Kubernetes on top of VMware, and I basically am responsible for the pre-sales experts in this space. So I'm going to talk for about 15 minutes or so, and then we'll pass it over to Pierre, and he's going to do the details on Wavefront with Kubernetes. Now, I'm going to go pretty quick. What I've done with most of the slides is that I've created a little link if there's further information available. This particular link here is a link to our Cloud Native Apps portal on YouTube, which has a ton of information. So when I go through a slide, you may see a link in the upper right. Get your screenshots ready. And you can grab that link and then go ahead and plug it in and watch the replay of that video, typically in a light word style. So I like to say containers are doing to operating systems what virtual machines did to server hardware back in the day. Now, the only big difference here is that there's this much quicker adoption cycle occurring. The value of containers and the amount of work that you have to do to get an app up and running is far less than it would be when you have to go in and configure an operating system and patch it and so forth. So huge adoption here in the market. Here's one statistic here from IDC. It was a survey done, and the expectation is 1.5 billion containers by 2021. And if you contrast that with the number of virtual machines that are deployed today, I think it's roughly about 60 million or so, if I'm not mistaken. You can see this giant scale of containers that's going to be estimated. And the reality is that each one of those containers is going to need a network connect to. It's going to need some sort of storage, and of course it's going to need compute underneath it. So we feel VMware is uniquely positioned here in that we own a lot of this infrastructure technology, and we're going to adapt it to work in the container world. Now, the interesting thing that I want to highlight here is that if you tell me you want containers, you understand the value. Containers, and specifically kind of the core Docker functionality that exists in Linux and Windows today, is that the Docker functionality is really about running one individual container. Now, business applications are usually a series of containers, and sometimes you have to orchestrate across those containers. In this case, I'm showing there's a Docker run a web server. Maybe I have two of those. There's a load balancer that sits in front of them. Maybe there's an app or a database tier. And just core Docker container functionality requires you to go in and issue this Docker run command to stand this thing up. What it doesn't do is manage the fault tolerance. It doesn't manage the upgrade of the business app per se. And so what we saw very, very quickly after containers took off is that there was a need to be able to orchestrate multiple containers and provide some sort of resiliency. And so that's exactly where Kubernetes comes into play. If I have a Kubernetes cluster, what I do is that not only do I define the containers that I want running, but I also define all the unique things that they may need, the quantity, how the services are presented to the external world, and so forth. So I'll have basically a text file or a few text files, and inside those specify the containers. Now, Kubernetes is the winner in the container orchestration wars. I don't think there's any debate there anymore. All the major container solution providers that exist all have announced or have Kubernetes support. All the major public cloud providers also have Kubernetes services available on them. Now, there is a challenge here with running containers in production, and this is a little bit older survey here. It's about a year ago, but a lot of this stuff still applies today. And if you look at kind of the majority of the challenges, they really exist here in security, storage, networking. These are These are fundamentally infrastructure type problems that are popping up in the container world. And that's why we think our solution, VMware PKS, is uniquely positioned to map those fundamental technologies up into the container world. Now, so I mentioned we have this product called VMware PKS. And sometimes there's some confusion in terms of what is VMware PKS and what is Kubernetes. Now, I just mentioned that Kubernetes is really about container or application scheduling. It's about providing resiliency of the app and figuring out how do I architect this app and run it. And then Kubernetes takes care of all the resiliency, any sort of upgrades. It gives lots of little mechanisms there. So you can think of Kubernetes as being responsible for the desired state of that application. But what about Kubernetes itself? What provides what provides the functionality to deploy Kubernetes and make sure Kubernetes can be upgraded and so forth? And that is exactly where VMware PKS comes into play. It is responsible for Kubernetes cluster creation, the scale of Kubernetes clusters, the resiliency of Kubernetes clusters, and just think of all the day two that's associated with managing those clusters over time. So think of VMware PKS as the desired state of potentially multiple Kubernetes clusters. A single instance of PKS with a single command line, you can deploy an entire Kubernetes cluster and make it available to your software developers. This is a joint engineering effort between Pivotal and VMware. Literally, the engineers and product managers from the company sit in the same office in Palo Alto and work side by side. So it truly is a joint offering between the companies. Now, PKS actually comes in two flavors. One is VMware PKS. The other one is VMware Cloud PKS, which is currently in beta as of this webinar. And VMware PKS is the joint engineering offering between Pivotal and VMware, and it is enterprise software bundle. So you'll download the software like you do with any other VMware product, you'll deploy it in your environment, and you will manage it and upgrade it and so forth over time. We have seen some demand for a SaaS version of this. So that is where VMware Cloud PKS comes into play. As you may know, VMware is starting to evolve a lot of different SaaS services, and PKS is also one of those. So I can go to my VMware portal and I can ask to deploy Kubernetes clusters with a single click, and it will deploy into public clouds. Now, currently in beta. So those are the two portfolio. Now, I'm going to spend time mostly talking about the enterprise software version, which is VMware PKS, because it is officially released. Both of the products are CNCF certified Kubernetes. More importantly than just carrying the certification of Kubernetes, meaning the Kubernetes clusters that are deployed will pass the minimum tests. We also have constant compatibility with GKE. So what this basically means is that as Google, remember they're the creators of Kubernetes, as they release new versions in GKE, we will be right behind them, usually within about a month or less for maintaining that same version that they have available in GKE. So it's not some sort of 6-month or a year cycle and so forth. We're on the same release cycle as Kubernetes. So let's talk about Kubernetes itself again in terms of how does it map to infrastructure. And if I'm going to architect in Kubernetes here, I've basically got my application developer. They're looking down at the Kubernetes API, and it's given them all these cool primitives to work with to, in this case, design their elk stack. So they're going to basically allocate resources, maybe some placement. They've got security policy. Maybe they need to define a load balancer, persistent volumes, and even they need to get some application metrics out of as associated with that elk stack. Well, Kubernetes gives you a way to define these things, but it doesn't actually provide the underlying technology. A good example is that a persistent volume, Kubernetes isn't a storage device. It just gives you a way to define it. And what that means is that I eventually need to take these different constructs in Kubernetes And I'm going to need a person that maps those different constructs into the actual technology that's performing the function. So namely, like persistent volumes, I'm going to need some sort of a storage device. I'm going to need a disk somewhere. From a load balancer, I'm going to need some sort of network product to do that, or load balancing product. Same thing with security, right? And eventually, the resources are going to need to land on a compute. So there's typically a team called this platform operations team, and they exist solely to do this for Kubernetes. So what we have done with VMware PKS here, because we own all these infrastructure technologies, we can, in a very prescriptive way, map each one of those technologies in Kubernetes, or the way to define the technologies in Kubernetes, down to our virtual infrastructure products. And so on their own, like NSX as an example, that gives fantastic benefit with any Kubernetes distribution out there. What PKS does is that it gives you a consistent and repeatable and upgradable way to actually create all these linkages. So you don't have to go in and hack away and write some configuration management to go do all this configuration. That is built in to PKS. So it removes a lot of the technical debt associated with running the platform. Now, I mentioned the ELK stack. So what's important for the platform operations folks to realize is they don't necessarily need to know the exact application that's running, like an ELK stack or Spark or whatever. What they need to focus on is simply providing these Kubernetes primitives so that the app devs can do whatever they want on top of it. Because we need to give them this playground, we need to give them the flexibility to be able to architect and create in a, call it, ticketless system. So provided we can give them a platform that gives them the native Kubernetes approach, which VMware PKS does, they should be happy. So I mentioned those challenges associated with Kubernetes. Remember that bar graph where we had compute, the complexity and the scale, the networking and the security, the storage, the monitoring, and so forth. So normally when I talk about all these things, now I'm gonna go very fast through these through the challenges. If you want to get more details on these challenges and how they're solved, you can see in the upper right hand corner we've got the PKS technical webinar we did this past summer, which has a detailed review of all this stuff. But let me give you kind of the high level here in terms of how it works. The corner, the heart of PKS and its ability to manage Kubernetes clusters is a technology called BOSH, which has actually been around since about 2010. And BOSH, its sole functionality is to deploy and manage virtual machines and manage their state over time. So hold that thought for a second. So when you deploy the VMs, you could potentially deploy them to any given IaaS. And the way we do that is we do that with something called the CPI, or Cloud Provider Interface. And all you need to know about the CPI is that it is a translator. Think of it as a translator. So I can architect how my VMs are put together in BOSH, and the CPI will take care of the heavy lifting of deploying to any given IaaS. vSphere, AWS, Azure, so on and so forth. Now, so what we've done with this core technology called BOSH, which is 8 years old, we've actually, and very mature, we've actually architected how to build a Kubernetes cluster as a BOSH release. So that gives us, the creators here of how to deploy Kubernetes, we only need to do that once, and then that CPI will take care of the heavy lifting to deploy to any given IaaS. Now, this is actually an open source project. All of the things in orange here are open source. CFCR stands for Cloud Foundry Container Runtime. So what about PKS? PKS contains the PKS control plane. It contains CFCR. It also contains private registry and these other things called service brokers. And so it contains all this stuff when you purchase it, and I'll go through that in just a minute. It also includes the integration with NSXT. So what we do with PKS, when it's deployed, we configure all this stuff. We feed it some very elementary information. In this case, I'm highlighting vSphere as the targeted infrastructure product. And so I'm going to give it information around vCenter. I'm going to give it the information around where NSX is, and where to store, and a couple of network things. But once I've done that, then I can start deploying Kubernetes clusters. Now, PKS also manages the day 2 of Kubernetes clusters, so scaling, patching, upgrades, and failures. So I'll go through that in a second. But once PKS is stood up, all I need to do is issue a single command line as the operator to create an entire cluster. So in this case, I'm highlighting creating a cluster minus N3. So that means there's going to be 3 nodes as a part of the cluster. So I just pass that to the API, and the system will automatically go out and configure all of the virtual machines, the entire Kubernetes cluster, completely wire up all the networking, create a default namespace, and completely have it turnkey. So then once the cluster is stood up, the only thing the user needs to do is get their credentials, and they're off and running with a native Kubernetes API. Now, I mentioned this is more the day 1 of the cluster creation, but the real power comes into the day 2. So in this case, I'm highlighting in that lower cluster that a node, one of the nodes becomes unresponsive. So the other thing that BOSH provides is an agent, and it knows what's up and running at any point in time. And if that node becomes unresponsive, BOSH doesn't try and fix it. It doesn't try and diagnose or troubleshoot. It deletes it and simply recreates another one. And this process of deleting and recreating as opposed to patching is how BOSH manages not only failure scenarios, but also upgrades and patching as well. Now the system, you can certainly scale the system with, once again, a single command line here. In this case, I highlighted, hey, I want 5 nodes instead of 3, and I grow to 5 nodes. Now, the cool thing, specifically related to Wavefront, is that when I deploy these Kubernetes clusters, I can automatically have Wavefront available and being used and able to be used for that end consumer. So that end consumer doesn't need to go out and create some sort of metrics or monitoring engine. They can literally have that already built into the clusters, and that can just be provided to them. So NSX, go through this pretty quick. A lot of times NSX is compared with open source solutions. So real quick, from an open source perspective, I think the thing you got to take into consideration is how many different open source projects are required when providing a complete network solution in Kubernetes. So Flannel is one that's sometimes highlighted, but that's only for layer 2 traffic between pods. Of course, NSX will provide that layer 2. Calico, if you want to get in and out of the cluster or provide security, you're going to need a technology called Calico. Of course, NSX provides layer 3 and layer 4 as a part of NSX. The culmination of those two is sometimes referred to as a canal, but that doesn't necessarily mean that there's like a single install or a single API you go to. They're still 2 separate products. Now, if you're designing a cloud-native product or software, most likely you're going to have a need for a load balancer. So in that case, on the right-hand side, you go with something like nginx, HA proxy. Load balancing is built into NSX. And so if you look at these 3 different technologies here on the right-hand side, if I have to go, number 1, set up, but more importantly, diagnose or troubleshoot or collect metrics out of anything, I'm gonna have to go to 3 different products. If you've ever tried to troubleshoot any sort of networking where you constantly have to go hop by hop and log in and run traces and all this stuff, it becomes very difficult across multiple products, open source or not. And so not only is it only Kubernetes networking, but there's 3 different products. Now, NSX, not only is it Kubernetes, it's across multiple Kubernetes clusters and also your virtual machines that may exist in your environment as well. So on the right-hand side, no end-to-end configuration and troubleshooting. That's kind of the big thing here that becomes difficult as you try to operationalize Kubernetes. And on the left-hand side, you've got NSX. You have full end-to-end visibility because you have that single source of truth for networking. Now, this is just a screenshot which highlights the single source of truth. There's a technology built in NSX called TraceFlow here, and TraceFlow will basically allow you to take 2 different pods or a pod and even a virtual machine, and you can do this trace, and you can see not only every step of the way like a trace route, but you can actually see some of the distributed firewall rules that get hit as a part of this. So it's very easy because you have this global view of everything networking to diagnose and troubleshoot problems when they come up. Now, monitoring operations. So, of course, we've got Wavefront here. Pierre's going to go through much of this here in his section. But in effect, what we're highlighting here is that Wavefront can be used in multiple and many areas of the stack and used by many different individuals, whether it's a site reliability engineer, a developer, an operator, and they can provide this great customized view depending on your specific requirements. And I'm not going to spoil it. I'm going to let Pierre take this in just a little bit. So again, with PKS, everything in red is what you get. So if you buy PKS, you get BOSH, you get the PKS control plane, and you actually also get NSX as well. So all your networking and full automation is taken care of as a part of PKS. PKS can run on multiple different IaaS solutions. Of course, I'm highlighting vSphere and vSAN here. vSphere and vSAN here can also run on public clouds such as GCP and AWS, with more in the future. On the left-hand side, you can see all our vRealize components. At the top is Wavefront, of course, and we'll get into that. But there's varying levels of integration with each one of those. Again, anything in red is what you get when you purchase PKS, and then you've got all these other integrations that exist from the VMware products family. So really comprehensive solution here. So again, when you're building your Kubernetes deployment and want to provide that service, do not underestimate the amount of different technology that needs to be deployed and integrated as a part of it. The stack is large, and to operationalize, just one thing like Kubernetes is, that you're going to have to do that, but to have to operationalize a whole bunch of other technologies along with it is tough. So I always like to say the least amount of new wins. And in this case, we've got our software-defined data center with vSphere, NSX, and vSAN. As we start to build this up from storage persistence, we got a vCloud storage provider as a part of Kubernetes. Of course, NSX for the Kubernetes networking. We've got BOSH for the life cycle of our vanilla upstream Kubernetes. And we also have Harbor, which is a container registry. And so you can see PKS covers a lot of this technology that you don't have to worry about integrating. So that's it for me. I appreciate the time. I'm going to send it over to Pierre now to talk specifically around Wavefront and Kubernetes.
All right, can you hear me just fine?
Yes, we can. We can see your screen. Awesome.
So welcome everybody. My name is Pierre Tessier, and I'll be taking over from here. Thanks a lot, Steve. That was awesome, and thanks for the intro and even some of the little feelers there. I run the systems engineering team for Wavefront. Been around for a while, the Wavefront team, and I'm happy to show you guys this great integration that we built with the two products, both Wavefront and the pivotal container service known as PKS. Before we get too much into it, though, I'd like to talk a little bit about the challenges associated with monitoring containers as a whole. As there's kind of three real big categories right here, and the first one we talk about this dead zone concept here. We see this a lot in the existing open source tooling today, where we'll use one specific tool to monitor the Kubernetes infrastructure, and then we'll use another tool or sometimes another cluster of the same tool to monitor the app aspect of it all. And trying to combine and correlate the two together doesn't make sense because the data is in separate systems. So you need one view to contain all of that aspect. Now, scale is a problem when this happens. Containers being up and down so much, they seem to generate a lot more data. And the reason why people kind of create different tooling is because one tool can't support the scale that they need to put everything together into one. The other part of that one is slow. And what we mean by that is actually fast. Containers can sometimes be very fast, short-lived things. And traditional monitoring that depends on 1 minute scrapes, you might not see a container actually come up and down during that 1 minute collection scrape, and therefore you never got the data associated with it. You never understood what it did because the data was never there. So being able to support collection sampling down over to the even 1 second, sometimes more frequent than that, is also very important. And finally, the last one here, blind spots. This has come to us actually, multiple people, customers have come to us and are now customers of Wavefront because of this right here. All monitoring tools out there in the world Behind the scenes, we use similar kind of technologies. Typically, they're key value stores that contain your time series data with a very wide indexes that contain all the data that you're going to be looking for and the actual data underneath it. In order for you to query the data underneath, you need an index to exist. And in the container world, each container generates its own ID, which in turn generates its own set of indexes times number of metrics. Oftentimes we do big deploys where we're going to spin up 10,000 brand new containers, all with brand new IDs to do a big app deployment. And when that happens, you bombard a monitoring platform with a bunch of brand new IDs. Wavefront, we're uniquely positioned with some patents around this to make these new IDs immediately available for query. So we essentially have a two-stage indexing system, if you will, one that is kind of live, still getting built, and one that is the built indexes. But we allow you to query the entire thing immediately. Other tooling and platforms, you could go up to 15 minutes without even being able to query the data that you're generating. So if you can imagine, you just did a big live, large production deployment, and you've got to wait 10, 15 minutes before you know if it works. That could feel like eternity. And in our world where we stress and we continue to highlight the real timeness of data, it's important to be able to support these kinds of things in these situations. And that's why, especially at the high data cardinality that comes out with containers, it's important to have a system that can materialize and index and render your data for you immediately. Continuing on with this this whole entire approach, and you know, what is Wavefront itself? Wavefront, we're a cloud native. We're born for the cloud, and we're a cloud native monitoring platform. In fact, we have our roots back in the very much nature of Kubernetes itself. We come from Borg, Google's Borg, or Borgmon, if you will, which was the nascent predecessor to container, Kubernetes, and even other monitoring platforms that came out of that works within Google. The other side of us comes from PayPal, which in itself had its own monitoring challenges, and they created a new tooling and a monitoring platform out of that, and we are largely inspired by that tooling. So together with Google, what we've learned at PayPal, and also what we learned at Twitter in terms of monitoring, we went out and we've created Wavefront, and we made monitoring for cloud native available to the masses in the form of a SaaS offering. Why are we different from our competitors? So one, like I continue to stress, is that cloud native, but we also had the unrivaled performance at massive scale. We could ingest over 4 million data points per second for a single customer. But at the same time, you could query that exact same data in under 1 second. So it's one thing to take in the data at massive scale. It's another thing to perform while you're doing that. We never roll up your data inside of Wavefront. And this is very key, especially for anybody who has any sense of seasonality to their lives. Right now, we're in the holiday season, and a lot of retailers, they're in busy time right now. Black Friday was 10 days ago. Really busy season for a lot of people, especially in the retail space or even the financial space. And things might happen. Things go down. Performance gets degraded. And you're going to want to take a look at what happened and come back to it 3, 4, 5, 6 months later so you can implement really good fixes and ensure it doesn't happen again. But if you roll up your data over time, if your 30-second collection data becomes 1 hour collection aggregates after 1 month, you lose the ability to really understand what actually happened. And in Wavefront, we never roll up your data. We allow you to go back anytime you want. Over 1 year, 18 months later, we will still have the original resolution data never rolled up for you to query exactly as you sent it to us. And with our advanced tagging and our love for high cardinality data, we also enable real-time iterative investigation. And what we mean by that is if you are looking into information, if you are trying to learn what's going on, something is going down, we invite you to enrich all your data all the time, and you could use that to slice and dice in real time with Wavefront. Eventually, you could use that bottom middle bubble there to drive a full stack correlation. a KPI of my transactions is acting odd, I could correlate that against anything else inside the Wavefront platform to see if something else resonates with it. Very easy to do in Wavefront. Our customers do this all the time. And we use that exact same querying and correlation capabilities to drive our alerting. So you can alert on what's really anonymous, what's really real. No more false positives, no more alert fatigue, because your alerts are more intelligent. And all these things combined together really allow you to drive to smarter questions, getting them answered. No more is it saying, I want to see a summary of everything, but now you can say, I want to see anomalies based on forecast models, or I want to see anomalies based on a standard deviation, because that's really what drives my business. With PKS, a lot of people like to call this the Happy Meal. I'm going to show you when we get to the demo just how easy it is to get started with Wavefront. It's literally just a couple mouse clicks. And once you're up and running, you're going to get a lot of rich information out of the box within Wavefront. It is really, you know, for those of you who like that kind of nomenclature, we are really a happy meal together. It's almost like peanut butter and jelly. We were really meant to be together as Kubernetes and Wavefront and PKS together. We really help you enable your developers while keeping an eye on them to ensure that we're not running wild, and what we're doing is really working out. Now, we wouldn't want you to be the first at this, and certainly you won't be. Our customers have been doing this for a long time, and they've been at it quite a bit, and they do it at fairly large scale as well. I'll just pick out a couple right here to talk about. Box in the upper left-hand corner, they're a very happy customer of ours, and you know, I should have probably pre-prepared this. This slide's actually a little old. They're pushing well over 25,000 containers now that they run live in production. Mixpanel does actually a full refresh of their entire infrastructure daily. So we understand they remuted the entire thing daily. That's all brand new IDs every time they do this, and we have no problem handling that kind of load with our platform. And even some large kind of your staple consumers, be it financial institutions or even energy providers or utilities commission, they're also on board in the container world, and they're making heavy use of Wavefront as well to ensure that they could do what they need to monitor at scale and do it quickly. But we don't want to limit you to just your Kubernetes infrastructure, because really that's not what it matters. If you remember, one of the first things I said is you need to combine the infra with the app to get that complete picture. Wavefront has over 180 different integrations growing on a monthly basis for all kinds of different applications and even new kinds of infrastructure as well, or different ways to attack infrastructure. And you can combine all of this with each other inside of a single dashboard, or even a single chart or a single alert. So you could do things like, if my edge load balancer is getting additional requests and my CPU load is high at the same time, throw an alert to drive an auto scaling action, so it auto remediate itself. Of course, you could do the opposite, high CPU with low activity on the edge load balancer, and we could do something different in that area as well. So all of this enabled to you by Wavefront, by our rich set of integrations that we provide. Now, with all of that, I'm going to move on and talk a little bit about the actual integration itself, and we're going to go ahead and show you some product of how this looks. So I'm going to start off with showing you the Pivotal Ops Manager screen. This is what you get when you set up PKS, or really any Pivotal Cloud Foundry product. That is you get these tiles to get going with PKS, and you would set up the vSphere tile as well as the Pivotal Container Service tile. And when you go inside of here, the next step you would do is you would configure your tile. There is a monitoring section as part of your PKS tile configuration. And inside this right here, you say, yes, I want to do my monitoring with Wavefront. You will provide your URL. In my case, my URL is called demo.wavefront. Today, most customers would have a URL called Longboard, though it may be different depending on who you are. And finally, you'll provide your API token, which is available to you inside the Wavefront product itself. This final item here is optional, up to you. If you specify it, PKS will go out into your Wavefront environment and create a series of alerts out of the box, ready, made just for you to monitor the infrastructure associated with the PKS environment. Even letting you know if your containers are running healthy, if you're getting too many restarts, that kind of stuff. So really handy out of the box. I'll go ahead and manage those for you. You are certainly able to change the recipient of these alerts later on, or even get rid of them. But this is an optional step for you to do. And once you hit save here, and you return to the installation dashboard, you then apply changes just like anything else you do inside of Pivotal. It'll go ahead and build your environment up with the Wavefront integration built into it. It'll do some errands behind the scenes. And when you're finally up and running, within minutes, you will see your Wavefront environment come to life. So what does that look like inside of Wavefront? I come in here, and we're looking at right here is the integrations page of Wavefront. I actually kind of pre-scroll to the middle of that page, but just kind of show you the vast number of integrations we have ready to go with Wavefront. And we're focused in here on the VMware PKS one. Inside this tile, we give you a quick overview, some sample metrics of the data flowing, and ultimately you go to the dashboards page and get to that dashboard very quickly that we pre-deployed for you. And that's this dashboard right here. Now, we've been running this environment for a while for PKS, and you can see the data coming in here and flowing in. Now, truth be told, my environment's not the super healthiest. You can see here I've got quite a few container restarts. I actually did a boo-boo. I did a mistake. I had a container that ran wild on a 1-hour cron job, and it was really chewing me up. And I left that there because I wanted to show you we all make mistakes in life. And Wavefront didn't miss my mistake. It captured it, and it realized I did something probably not super healthy. And you can see here, we've got some red and orange things here saying, hey, your environment's still not healthy. You need to work on that. And I left these like that to show you that Wavefront is definitely aware of all these things and did capture it for me. Even flag some events behind the scenes to say, hey, we've got stuff that's going on. And you can see here, it says anomalous CPU usage even that we have created for us by that PKS environment. So this is the default dashboard that we get. It's got all kinds of information broke down by overview, by the nodes, namespaces, pods, and containers, so on and so forth. And you get to any of these sections quickly to better understand what is going on. So if I go to the pod section, we'll go ahead and come right here. I'm just going to slide this over to a 10-minute view so we could refresh all these charts a little faster for us. And it'll tell us exactly what is up with the pods. You see I got one here with much higher CPU usage than the other. And the reason is a little bit after Steve started his presentation, I actually kicked off a load test on an application that we're going to talk about here in a few minutes. So coming back to Wavefront and what it is, why do we run Kubernetes? We run them for applications, and we also created a small application. We call it PlaneSpotter. PlaneSpotter is a small Kubernetes application. It's made up of about 5 different microservices. It's got an nginx front end to route some API calls to the various PHP-based Flask applications. It's got a Redis database, and it's got also a MySQL service. I could go to the app health check, and we're going to go ahead and tell you how all those 5 microservices are working so we get a sense of what's going on with our application. This is an application called PlaneSpotter. It really goes out every 5 minutes to an FAA database or to an FAA service, and it goes and gets the location of airplanes over the sky in North America. It also has a database of pretty much every plane that is owned by airlines in the world as well. So I could come here and say Delta Airlines, for example, and I care about 767 airplanes, and I could search for that, and it'll go out and go find all these Delta 767 planes for me. I went to the next page, and I can see one here is highlighted in green, and this tells me that this plane is currently airborne. So we go ahead and click on this one, and then the service will then go out and we'll get a little bit more information about this plane. It is going from London Heathrow to Denver, so it's flying over the Atlantic, and we get a little on lat. I click on that, and the app goes out and will map this on Google Maps for me, so it's somewhere over northern Ontario in Canada on its way to Denver. So kind of a handy little app, if you will. might serve some usage for people who are perhaps frequent flyers. Now, the reason why I'm talking about this is this app is made up typically of any other app you're going to deploy in Kubernetes. A lot of different microservices. And we're only using 5 here, but we're trying to showcase what can be done. Up front, I told you it was nginx, MySQL, Redis, and some custom applications that we had built in PHP. Now, in Wavefront, because we had the integrations enabled via PKS, we were able to flow the nginx stuff in here right away as well. So immediately, my nginx dashboard showed up inside of Wavefront, and here it is right here. I go ahead and click on this, and I could see what is going on with the nginx side associated with our application. Yeah, pardon me here, my network seems to be a little hokey. There we go. And we can see here, you actually see the load just kind of picked up and it's going off, and we could see something is happening within our application itself. I got one server that's really loaded up pretty hard right now. We also have MySQL, which also appeared. We had Redis, which also appeared. But we don't expect you to monitor these things in isolation. We don't expect you to look at just your PKS dashboard for infrastructure and just your nginx stuff for how the front end is working. We expect you to look at things in a full stack view. And at Wavefront, what we're trying to do with our integrations is provide you all those building blocks you need to build your exact view. So when I come in here, I could be looking at a specific chart, and maybe this chart is interesting me. This is really what I want to drive off with. This is accept rate. It's interesting in my full stack view. You could scroll down to the bottom, and right here, you can insert it into any dashboard. And I've created one right here for the PlaneSpotter PKS app. And when I hit insert, it's going to go ahead and find that dashboard for me, take the chart I was looking at, and insert it into that dashboard, editing inside of edit mode, ready for me to go. And then from here, I'm free to edit my dashboard to exactly the way that I need this to be. So maybe I really want this chart to be up here next to that one right there, and I want MySQL commands to be right next to it. Okay, and I want this row to be a little bit shorter, so it looks more like this. Maybe this is exactly what I'm looking for. All I got to do at this point is hit save, and I'm ready to go. And I can continue to build that dashboard to that exact view I'm looking for and share this with my colleagues. Now, I've already gone out and done that. So I'm going to go ahead and cancel this, and let's go to that view. And here it is right here. You can see that load I kicked off at the earlier point of this phone call, just not even an hour ago, about 30 minutes ago, we started a load on it. And you can see all the metrics from the overall to the front end, which is nginx. We go look at the Redis stuff right here. Just below that, we've got how MySQL is performing in detail. And then we get into the Kubernetes metrics themselves. And you can see that alert firing off, which is actually one of those anomalous things that we had set up that said, hey, we see anomalous action on the CPU load for one of your machines in Sunnylab. And it fired an alert on us to tell us something is up. All this done driven automatically for me behind the scenes. So really handy stuff to help you get to where you need to go immediately within your infrastructure, within your applications. And by deploying PKS, enabling your developers to push code more rapidly, to push infrastructure how they want, while giving them a platform to get immediate insights into what they're doing, really allows you to accelerate and innovate at a much rapid pace. As the saying goes, disrupt or be disrupted, right? If you're not innovating, your competitor is. PKS with Wavefront allows you to do exactly that, innovate. So with that, we only have a few more minutes left before the end of this webinar. I'd love to open it up to questions. So if you have any questions itself, if you could go ahead to the chat or QA panel and go ahead and post your question, I'd be happy to answer them. And while we're waiting for questions to come in, if you're interested in Wavefront, really easy to get started with us. Just go to wavefront.com. You can click on the free trial button, upper right-hand corner, or just wavefront.com/sign-up. If you have any questions about PKS, you can see the URL right there, so you can learn more about it as well. And if you would like to learn more about a webinar that we produce, or even get this link recording later on, you can see the URL right there, bit.ly PKS webcast. So one question I got here, it's how do we monitor the individual applications themselves? How do we get metrics? We have multiple ways to do that for Kubernetes. One of the ways is to go after your Prometheus endpoints, which is a really popular way. We will automatically grab them. We will scrape them for you. We have a drop-in wonderful replacement for Prometheus. Another way is to do what we call is sidecar. It's a concept known where with your application, you deploy a very tiny container next to it, which will periodically collect data from your pod itself and send them up over to Wavefront. So both of those models work very well. We do document them also and explain to you how do you go ahead and get moving forward with them. Finally, with Wavefront for your custom applications, we can provide you an SDK. We support all the popular languages out there. And we also have some well-known bits to work with existing metric libraries already. Wavefront itself is an open data platform. We're not going to opinionate you on a specific way to collect your data. We're going to work with how you have it today, and we'll enhance it.
Just wait and see if there's any last questions. If not, we're getting close to our allotted time slots. We'll just wait. If there's any last questions anyone has, please type them in. I see a few more coming through.
Sure. So I see a question here about to please help elaborate between the difference between vRealized operations and Wavefront. There's some overlap between the two products. We do understand that at VMware, and we clearly see that, particularly around monitoring. But vRealized operations, you'll see this increasingly as well, is putting a lot more effort into the management aspect of your virtualized environment, including your virtualized PKS environment on vSphere. And what I mean by that is workload placement, capacity management, vMotions. Those kinds of things are still very important in a virtualized world, and vRealized operations provides a great mechanism for you to do that. It does need data to drive those mechanisms, and therefore it's always needed. But when it comes to monitoring big, massive scale applications, with data resolution down to the 1 second level, Wavefront is the kind of the stalwarts there. More performance, more scalability capabilities, and a more diverse analytics language. Wavefront is a SaaS-based service only, and vRealized operations is installed on premise. So there's other differentiators there as well.
All right, looks like questions are kind of dying down. So we will wrap this up. I just want to say thanks to both of our presenters. And again, if any of you online have questions, please reach out to any of the websites or emails on this resource page. And just as a reminder, we are going to be sending out this recording to all of you who are attended today so that you can be able to reference back to this as well. So with that, we will sign off, and thank you, everyone. Thank you, Pierre. Thank you, Steve.
Thank you, everybody.